Racket is a functional programming language which has been used in education since 1975. It is a dialect of the language scheme and it's part of the Lisp family of languages, the Lisp processing languages. Um, if you're watching this video, it's highly likely that you're being taught Racket at university, as this is usually an introduction course to build up logic skills. And I'm going to try to cover the basics in this video and make some more videos in the future which cover some more complex parts of DrRacket and hopefully give you a good start. To begin with, Racket has three types of data. It has values, it has expression, like not even data. It has values, it has expressions, and it has functions, right? Values can be numbers, strings, symbols, etc. We'll learn more about these as we go on. Let's just worry about numbers for now. I just typed 5, right? And I run my program. It's gonna output what you expect. It's just gonna output me 5 because it's the simplest form, and 5 cannot be solved any further, and that's what Racket has to do. Like it just gives you 5, and so this is a value, and I can type multiple values. I can do 5, 6, 7, 8 on different lines, and when I run it, this is what Racket's gonna output me down here. Oh, this is called the interactions window. By the way, this area here is the interactions window, and this is the definitions window where we write our code. Anyway, so basically, if you type numbers, if you type values, it gives us exactly that. If we type strings, which you don't have to worry about too much for now, but later strings are text enclosed in double quotes, and if I run that, it's literally just going to give me that back. So because that's what show value as well. And then there are expressions which combine these values. So let's say I'm adding two numbers, I can do plus 3, 4, and it's gonna give me 7. More on why we do the operand first and then the numbers. This is called the infix notation. I'll get to that in just a couple of minutes. And then there are functions which allow you to do computation and generalize expressions. Um, let's look at that in a little bit more detail. So, um, in normal programming or everyday arithmetic, we use something known as the infix notation, as I just mentioned, which means that we specify our expressions with the operands between their values. For example, 3 plus 4 plus 5 plus 6, or 6 plus 5 minus 2. And these lead to issues when addition and subtraction get mixed with multiplication or division. For example, this expression right here, 3 plus 4 by 5 plus 6, how do we know if it's equivalent to 3 plus 4 by 5 plus 6 or 3 plus 4 divided by 5 plus 6? So in Racket, we use something known as the prefix notation. So there is no ambiguity regarding this. So we would write things as plus 3, 4, 5, 6, or minus 5, 2, or divide by 6, 3, 2. And this basically, so like plus 3, 4, 5, 6 is the equivalent of 3 plus 4 plus 5 plus 6. And if you run that, that's what it outputs, 18. And let's say I do divided by 6, 3, 2, that's the equivalent of 6 divided by 3 divided by 2. So that should give us 1. And yep. And so the prefix notation actually helps when we get to complex inquiries like something like this, right? Where there's ambiguity using infix notation unless you use extra parentheses, which just looks messy, and that's not what we do functional programming for. And so we can do something like that. So what's the outermost, let's say we have to evaluate this, right? Let's try and do this. So what's the outermost thing happening over here? It's being divided in the end, right? So the outermost operator here is divided by division operator. So we're dividing the sum of 3 and 4, dividing the sum of 3 and 4 by the sum of 5 and 6. And using prefix notation, it's so much more clear. And I could add like a bunch of more terms over here. And there's never going to be any ambiguity regarding what the order of this division is. And maybe I can add a bunch more terms here. If we run this, we'll get an answer 0.18 bar in this case. Moving on, Racket also has more than operators. There are some existing functions that are like functions you can make yourself. We'll get onto that in a bit. Um, so for example, there are functions like square of 2, and that's going to give us 4, right? And oh, let me just delete this from here so it doesn't mess up our interactions window again and again. So square of 2 gives us 4, and then there's also like square root. Let's do like square root of 100, and that's going to give us 10. So 4 and 10, and expd, which actually stands for exponent. So exponent of 3 to 2, which basically means 3 raised to the power of 2, or 3 squared. So it should give us 9. And yep. And so these are, if you look at them, these are similar to like actual math functions. Like this is similar to an actual math function, which looks like fx or fx, and this is like fx and y. And that's how you define sort of functions in Racket. Racket has something known as definitions, which can define constants as well as expressions of functions. So we can just define a 5. Sorry, let me just delete this again so it doesn't mess up our interactions window. So define a 5, and if I run it, it's not going to give me any output because we just defined something, but I can play around with it. And if I just type a over here and then run it again, it gives me 5. So it's like a value now. A is now a value. A itself doesn't stand for anything, but now we define it to be 5, so now it's 5. Similarly, we can define more constants, define A5, define B10, define C15, and then we can add all of them up. Add A and B and C, and it's going to give us what you expect. It's going to give us 30. So that's how, but this is how you define constants. This is usually used for readability. For example, you usually do something like define cost per meter 0.15, and then you do something like, I don't know, like multiplied by cost per meter 100, and that's just easier for you to read than doing into hundreds. Obviously, like you won't use it for just this much. I'm talking if you ever have a more complex program, but that's for readability, right? You see what I mean. And but you can also define like functions in the fx, fxy form or something like as you mentioned above. So you can go like define, let's say, let's try and define something like f of x equals 5x, right? So define fx product of 5 to x. So you see this defined structure is different than the ones we use to define constants. When we define constants, we don't enclose them in parentheses. However, here we do. This is because it is important that define knows how many parameters are being paused. Like f is the name of the function. This can be anything. This can be return 5 times of x, and x is the parameter over here, which means we can pass one number to this function and it's going to give us this. So define takes in 2 arguments itself, always. Define takes in a name, either a variable name, or it takes in a function name with all the parameters it's accepting, and it takes in either their value or an expression for them. So now if I do return 5 times 10, and run this, it's going to give me 50. And I can do like return 5 times a over here, it's going to give me 25. Return 5 times 100, give me 500. And also you can just use this for renaming stuff. Like I can do define b of x to be return 5 times of x. And now it's just a shorthand. I can just do b of 100 now and it'll give me 500. So yeah, that's how definitions work. Pretty sick. That's all for this video. I'll see you soon.